Section 5, Analysis of Equipment Technical Status and Operational Economics. Part 1, Equipment Technical Status. The technical status of equipment refers to the working capability of the equipment, including performance, accuracy, efficiency, operating parameters, safety, environmental protection, energy consumption indicators, and the state of these factors and their changes. Through daily inspections, periodic checks, including performance and accuracy checks, lubrication, maintenance, adjustments, daily repairs, condition monitoring, and diagnostics of in-use equipment, including stored equipment, using the technical data and information collected through these activities for statistical analysis. This allows for timely judgment of changes in equipment accuracy, performance, and efficiency. It helps detect or predict functional failures and faults early. Timely repair or replacement measures can then be taken. This ensures that the equipment remains in good technical condition. The main statuses are classified as fault state, good condition, and scrapped state. The standards for the good condition of a single piece of equipment in the chemical industry are: first, complete and intact components, quality meets the requirements. Second, the equipment operates normally. The performance is good. It meets the rated output or inspection capacity. Third, complete and accurate technical documentation. Fourth, equipment and environment are tidy and clean. There are no leaks, drips, or spills. Part 2, Detailed Analysis of Equipment. The technical and economic performance of equipment during the operational phase is mainly reflected by the equipment's operating rate and load factor. The operating rate is measured based on time. The load factor is measured based on output. Both represent the utilization level of the equipment. The operating rate of equipment refers to the percentage of actual operating time of a single piece of equipment within a specified time compared to the calendar time. Actual production capacity refers to the total output or capacity of equipment producing products during the statistical period. Design production capacity of equipment refers to the designed output of the equipment during the statistical period. The operating rate and load factor of equipment directly affect the product's cost and profit. Product costs are divided into variable costs and fixed costs. Variable costs refer to the costs of raw materials, labor, auxiliary materials, maintenance, etc., consumed by the product. Fixed costs include equipment depreciation, management fees, taxes, and so on. The variable cost per unit product can be considered constant here. However, the fixed cost per unit product is related to the operating rate of the equipment. By improving the operating rate of equipment, the fixed cost is distributed across the unit products, thus reducing accordingly. Therefore, the unit cost of the product decreases as the operating rate of the equipment increases. How to determine if a piece of equipment is economical? You can calculate the unit cost of the product. The formula is total cost, that is, fixed cost plus variable cost multiplied by operating rate divided by total units produced. Here is an example question. Solution. From the listed items and expenses in the table, we can see that the fixed expenses and operating costs for equipment are: depreciation cost 58 yuan, operating cost 130 yuan. The fixed expenses and operating costs for equipment are: depreciation cost 116 yuan, operating cost 270 yuan. If the monthly production requirement is 4,000 units, the rated operating time is 7 times 24 equals 168 hours. That is, 24 days per month, with 7 hours per day. Thus, the time required to complete 4,000 units is: for equipment A, 4,000 divided by 25 equals 160 hours. For equipment B, 4,000 divided by 76 equals 57 hours. The operating rates are: for equipment A, 160 divided by 168 equals 95%. For equipment B, 57 divided by 168 equals 34%. The cost of producing 4,000 units of the product is: The formula is total cost, that is, fixed cost plus variable cost multiplied by operating rate divided by total units produced. For equipment A, 58 plus 130 multiplied by 95%, all divided by 4,000, equals 0.045 UA. For equipment B, 116 plus 270 multiplied by 34%, all divided by 4,000, equals 0.052 UA. This shows that the cost of equipment A is lower than that of equipment B. Here's an assignment for you to complete after class. Using the formula just mentioned, compare the costs for producing 7,000 units. That's all for today's lesson. Thank you for watching.